Playing with numbers. In this chapter, we are going to learn about the divisibility rules. We also learn about factors, prime numbers, composite numbers, and factorization. We also learn about HCF and LCM. Let us start with the divisibility rules of different numbers. Let us start with the divisibility rule. What is divisibility rule and how does it help us? Here we see an example. Here is a girl named Hasini and she is going to celebrate her birthday. So she wanted to distribute chocolates in her classroom. She has 25 classmates. Her father brought 125 chocolates for distribution. So she has got 125 chocolates and there are 25 members in the class. Now she wanted to distribute the chocolates equally among their friends. So what she is doing now, she is grouping them 3 chocolates each. So that she wanted to give 3 chocolates to each of her friend, and at the same time she wanted to distribute all the 125 chocolates. So when she is making groups of 3 chocolates, some of the chocolates are remaining. So what she has done, she decided to make 6 chocolates into group. She wanted to give 6 chocolates to each of her classmates. So then there is a shortage. She is not able to find how many chocolates if she distribute to each of her classmates, then all these 125 will be exactly sufficient. Here in this case, the total number of 125 and the number of classmates 25. Simply if we carry out division, we will come to know the answer how many chocolates can be distributed to each of the classmates, so by that is balanced. Here we know if we do the division process, we will come to know the answer. If she distributes 5 chocolates to one student, all the 25 will be distributed without any remaining. So we know that by division, but some cases here it is 125 is a small number, so we can find out just by doing division. Sometimes the number may be big. For example, she wanted to distribute these many chocolates. Now how can we do that? Here this also can be done by division, but it is a very big number and it is difficult to divide that number. The division is a big process, takes a lot of time. Now we are thinking, is there any simple method to find out a number whether it is completely divisible or not by another number? There are some methods. By following the divisibility rules without carrying out the division process, we can easily find out whether a given number is divided by the other number or not. Without doing the division, by using a divisibility rule, we will be able to find out whether it will be completely divisible or not. So that is the use of divisibility rule. So what is the benefit? Instead of doing the whole division process, we can easily find out whether the division will be complete or not. Factors. What are factors? Let us understand the concept of factors with an example. Devi is having 6 coins with her. Now she wanted to arrange these 6 coins in some arrangements, but in every arrangement she wanted to maintain same number of coins per each column. Now let us see. In the first arrangement, Devi kept all the 6 coins in 6 columns. So this is the arrangement 1, 6 coins in 6 columns. That is 1 coin per 1 column. Now let us see the second arrangement. So in this second arrangement, she arranged in 3 columns, 2 coins per each column. And in the third arrangement, she arranged in 2 columns 3 coins per column, and in the 4th one she arranged in only 1 column all the 6 coins. So these are the 4 patterns in which she arranged the coins. The number is same, 6, but the arrangement pattern is different. So here 6 columns and 1 each. Here 3 columns, 2 in each column. Here 2 columns, 3 in each column, and here 6 coins in 1 column. 1 into 6. So this is the arrangement. So now we can say that for 6 number, 2 into 3. 2 and 3 are factors of 6. We call this 2 and 3 are factors of 6 because these numbers divide the 6 exactly. So we call these 2 numbers are the factors of 6. 2 is a factor of 6, 3 is a factor of 6, because here how it is expressed, this number 6 is expressed in the form of its product, 2 into 3. So these 2 are the factors of 6. In the same way, the 6 is expressed in different way, 1 into 6. So 1 and 6, these 2 are also the factors of 6 because they divide the 6 exactly and completely. So 1, 6 also the factors of 6. So the factors of 6 are 1, 2, 3, 6. 1, 2, 3, 6. These are the factors of 6. Now we understood the factor. What is a factor? A factor of a number is the number which divides it completely. Say for example, you say 2 is a factor of 6. When can you say that 2 is a factor of 6? When 2 divides 6 completely, you can say 2 is a factor of 6. When we say one number is a factor of other number, the factor should divide that number completely. So here 1, 2, 3, 6 are factors of 6. Now let us try to learn some more things about the factors. So here we have some numbers and here we have their factors. Say for example 12, these are the factors. By observing this table, we will find some important things about factors. Here if you observe carefully, for all the numbers, 1 is the common factor. See, for any number you take, 1 will be its common factor. And the other thing we observe, every number, it itself a factor for it. Say for example 12. In 12 itself a factor for 12. 18 itself a factor for 18. And one more important thing we observe, the number itself, it is a factor and it is the greatest factor among all its factors. Say 18. 18 is the greatest factor among all its factors. So any number you take, whatever the factors it may have, all the factors are equal or less than itself. But no number is greater than. For example, see 20. So its final greatest factor is 20. We don't find some 22 or 23 here. So no more number more than itself becomes a factor. So a factor of a number equal or less than itself. So 20, its greatest factor is 20. So other numbers, other factors are smaller than 20. So that is the other thing we observe. And one more important feature of a factor we can find is that the factors of a number are limited and countable. Say for example 12, it has limited number of factors. We can count the number of factors. Let us see prime and composite number. See here, if we observe this 2, 3, 5, 7, they have only 2 factors. So among these factors, they have 1 as a common factor and the second factor is the number itself. Say for example this is 2, it is having 1 and 2 as itself as a factor. So such numbers are called as prime numbers. So 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. So what is a prime number? A prime number is a number which is having only two factors. Among that, one is 1 and second factor is the number itself. Such numbers are called prime numbers. So this is a prime number and this is a prime number and this is a prime number. So 2, 3, 5 and 7 are prime numbers. And let us look at 4 and 6. They have 1 and the number itself and some other factor. Such numbers are called composite numbers. Here 4 and 6 are composite numbers. And whereas this 1 is neither a prime number nor a composite number. Co-primes. What are co-primes? Let us take two numbers 3 and 8. Now write the factors for 3, 1 and 3 and for 8, 1, 2, 4, 8. So if we observe the factors of 3 and 8, among these factors only 1 is common among them. No other factor is matching. So such numbers are called as co-primes. That means the numbers that have only 1 as their common factor, those numbers are called co-primes. So here 3 and 8 are co-primes. Here we see two more numbers 3, 5. Here you observe this 3 and 5 are prime numbers. Now factors of 3, 1, 3. Factors of 5, 1, 5. So now can we call these two as co-primes? Yes, these two are co-primes because these two numbers are having only 1 in common. So among their factors only 1 is common. So you can call 3, 5 as co-primes. And even these two numbers are prime numbers. So here we can understand one relation that two prime numbers can become co-primes. That is, all prime numbers are co-primes. But all co-primes need not be prime numbers. See, these two are co-primes, but they are not prime number. This is not a prime number. Of course, 3 is a prime number, but 8 is not a prime number. So here we can understand that relation. What is that relation? All prime numbers are co-primes because they are having 1 in common. But all co-primes need not be the prime numbers because see this example 3, 8. So 3 may be prime number, but this is not prime number. So all the co-primes need not be primes. What are twin primes? Here we have some prime numbers 3, 5. So the prime numbers that differ by value 2 are called twin primes. What are twin primes? The prime numbers that differ by value 2 are called twin primes. So here 3, 5. Their difference value is 2. Both are prime numbers. So these two together called as twin primes. Even you see 5 and 7, the difference is 2. Both are prime numbers. So this is a twin primes. And here 11, 13, the difference is 2 and both are prime numbers. And even 41, 43. So these kind of numbers are called as twin primes. Prime factorization. What is prime factorization? Let us see what is factorization at first. Say for example, we have a number 6 here. If you write the number 6 as a product of 2 and 3, 2 into 3, 6. Now we expressed this number as a product of its factors 2 and 3. So writing the factors or expressing a number as a product of its factors is called factorization. So here factorization of 6 is done. So now we can say that 6 is factorized. The 6 is factorized because we have written the factors for 6. So this process, the process of writing the factors of a number is called factorization. A number can be factorized in different ways. Let us see an example. Let us take 24. So 24, we can write 24 as 1 into 24. That is 24 as a product of 1 and 24. So this is the one way we factorized it. We have written the factors. Now we take the second example where 24 is equal to 2 into 12. 12 to 24. So we have written the 24 as a product of 2 and 12. Now we take the third incidence 24 is equal to 3 into 8. 3 8s 24. So here we have written 24 as a product of 3 into 8. This is the third way. Now let us see the fourth way of factorization here. 24 we can write 4 into 6. 4 6 24. Now we have one more way to write 24. 2 into 2. 2 2s 4. 4 into 2. 8 8 into 3. 24. So in this way also we can write the factors for 24. This is the fifth instance. Now let us observe the difference. Here also 24 is factorized. Here also it is factorized. It is factorized. It is factorized. So everywhere the factorization is done, the factors are written. But in this case, 24 is equal to 2 into 2 into 2 into 3. So 2 is a prime number and this 2 is a prime number. This is a prime number. This is a prime number. So here, when the 24 is factorized here, all these factors are prime numbers. Whereas in other cases, some are prime and some are composite. So this is a prime number, this is a composite. This is a prime number, this is a composite. This is a prime number and this is a composite. And this is a composite and this is a composite. But here, if you see, all the factors are prime numbers. So this kind of factorization is called as prime factorization. So this is called as prime factorization. 7 ones. So we write it as 2 into 3 into 7. 2, 3, 7. These are the factors of this 42. So the 42 is factorized here. Now we can see that all these three are prime factors. 2 is a prime factor, 3 is a prime factor, 7 is a prime factor. So here the prime factorization of 42 is done in division method. Now let us see the second method, factor tree method. Let us take a number called 60. Now we are writing this 60 as a product of two numbers, 4, 15. So 4 15s 60. Now we are writing the prime factors for this 4, 2 into 2. So these two are prime numbers, which are the factors of 4, and here 2 into 3. The product of 2 into 3 is 15. So here we write 2 into 2 into 2 into 3. That is equal to 60. So 60 is factorized in 2, 2, 2, 2, 3. All these are prime factors. So this is the prime factorization of 60 in factor tree method. Common factors. Here we have number 12 and 18. Let us see their factors. If you observe the factors of 12 and 18, among these factors, some factors are common. Say 1, 2, 3 and 6. So here 1, 2, 3, 6 are common factors for both 12 and 18. So what is a common factor? The numbers, if they are the factors of all the given numbers, they are called as common factors. So these numbers are factors for 12 and 18. So they are the factors for both the given numbers. So we call them as common factors. Highest common factor or HCF. What is highest common factor? In the previous example, we have seen the factors of 12 and 18. What are the common factors of these 12 and 18? 1, 2, 3 and 6. So these four are the common factors of 12 and 18. Among these common factors, which is the greatest factor? 6 is the greatest. So the 6 is called as HCF of 12 and 18. What is this HCF? Highest common factor. Among the common factors of the given numbers, the highest number is called the HCF of 12 and 18. So the HCF of 12 and 18 is 6. So from this example, we will understand that HCF is the highest common factor of the given numbers. So these two numbers have these factors. Among these factors, which is the greatest number, that is the HCF of these two numbers. Let us see that prime factorization method. So we have to find out that HCF. How to find out HCF? There are some methods to find out HCF of the given numbers. One of such method is prime factorization method. Using this prime factorization method, now we are going to find out the HCF of the given three numbers. We are given with 12, 30, 36. Now let us find out the HCF of these three numbers using prime factorization method. So let us put 12 here, 2, 2, 6, 3, 2 and 2, 1. So 2 3s 6, 6 2s 12. So these are the factors, 2 into 3 into 2. Now let us see for 30. Here we put 2, 15, 3, 5. So here 5, 1. Now we put 36, 2. If you put here 2, it becomes 18, 3, 6, 3, 2, 2, 1. Thus, the factors of 12 are 12 equal to 2 into 3 into 2. Now the factors of 30, we write 2 into 3 into 5, and factors of 36, 2 into 3 into 3 into 2. So now we take the common factors. So the common factor factors are 2 into 3, that is 6. So the HCF of 12, 30 and 36 is 6. Now let us find out the HCF of 40, 56 and 60 using division method. Now let us take first two numbers, 40, 56. After finding the HCF of these two numbers, now we can find the HCF of the other number. First, we are going to find the HCF of these two numbers 40 and 56. In division method, first we have to divide the bigger number with a smaller number in the given numbers. So here, these are the given numbers. We have taken the big number 56 here and 40 here. Now carry out the division till we get the remainder as a 0. So here we got 16. We didn't get the remainder 0. So what to do now? Now we have to take this remainder as a divisor and divide the first divisor here, 16, 2's, 32 and 8 is the remainder. So now again take this divisor here and divide 8 2's, 16, 0. So here finally we got 0 as a remainder. Now the last divisor is taken as HCF of these two numbers. So HCF of 40 and 56 is 8. So now what to the next step? Here we found the HCF of 40 and 56. Now take this value 8. Now you find out the HCF of 8 and 60. So in the division method, the bigger number should be divided with the smaller one. So how many times? Here 8 7's 56. So here you got the 4. Again divide the 8. 4 2's 8 0. So here we got the 4. So the HCF of 40, 56 and 60 is 4. 4 is the HCF. This is the division method of finding HCF of the given numbers. What are common multiples? That means these numbers are divisible by 4. These numbers are divisible by 6. So these are the multiples of 6 and these are the multiples of 4. Now among the multiples of 4 and 6, we find certain numbers in common. What are they? See 12. 12 is common among the multiple of 4 and multiple of 6. And in the same way 24. 24 is common for both 4 and 6. 24 is a multiple of both 4 and 6. Now what else is common? You see 36. 36 is common among 4 and 6. It is a multiple of 4 and even a multiple of 6. Now what's next? Here, till here we don't have any other matches. So these three numbers are the common multiples of 4 and 6. Least common multiple, LCM. Let us see what is LCM. We have seen the common multiples of 4 and 6. What are the common multiples? 12, 24, 36. So these are the common multiples of both 4 and 6. So out of these common multiples, the lowest one is called as least common multiple. So the least common multiple of 4 and 6 is 12. So 12 is the LCM of 4 and 6. From this example, we have learned what is LCM. LCM is the least common multiple of the given numbers. So the given numbers, they have got some multiples. Among the multiples, the least common multiple of the given numbers is called LCM. Let us find the LCM through prime factorization method. Here we are given two numbers, 36 and 60. Let us find out the LCM of 36 and 60 by this prime factorization method. Here we write 36 and 60. So this 36 is written as prime factors 2 into 2, 4 into 3, 12 into 3. So 2 2 is 4, 4 3 is 12, 12 3 is 36. Now let us see that 62 into 2 into 3, 2 2 is 4, 4 3 is 12, 5s. 12 5s, 60. So among these factors, these 2 into 2 into 3 is common for both 36 and 60. Now let us take the common factors of both the given numbers 36 and 60, 2 into 2 into 3. Now into the other numbers. So these are the common prime factors. 2 into 2 into 3 are the common prime factors of both the numbers. Now the other numbers of both the given numbers. 3 into 5. 2 2 is 4, 4 3 is 12 into 3 into 5. 12 3 is 36, 36 5 180. So 180 is the LCM of 36 and 60. So 180 is the least common multiple of these two numbers, and we found it through prime factorization method. So in this method, first we have written the prime factors for 36 and 60. We have written the factors. Among the factors, we have taken the common factors. Now we are making the product of the common factors of both the given numbers and the other numbers, the leftover numbers, the other numbers we have written here. Now the product of all these numbers gives us the least common multiple of these two numbers. Let us find the LCM by division method. We have 21, 35, 42, these three numbers. Now we have to find out the least common multiple of these numbers. Let us find the LCM in the division method. First write these numbers horizontally. Now take a least prime number which at least divides two of the numbers given. We take 7. 7 3 is 21. 7 5 is 35. And 7 6 42. So here 3 numbers are divisible by 7. Now let us take 3 ones, and let us write the 5 as it is. It is not divisible. 2. So here we got 1. 7 into 3 into 1 into 5 into 2. So here we cannot find any other prime number which divide at least 2. So we stopped the division here. So 7 into 3 into 1 into 5 into 2. 7 3s 21. 21 5s 105 into 2 210. So 210 is the LCM of these 3 numbers. The LCM is 210. So here we arranged the given numbers horizontally, and we have taken the least prime number which at least divide 2 numbers here, but here it is dividing all the 3 numbers. We wrote here, and we have taken one more prime number, so which is dividing at least 2 numbers, this number, this number. So 3 dividing 3 one time, and 3 not dividing 5, so we have written the 5 as it is, and 3 is dividing 6 2 times, so 2 we have written. Now here we don't have any other prime number which at least divide 2 number. So in no prime number can divide any 2 number here. So these 3 are prime numbers, these 2 are prime numbers. So here is 1. So there is no possibility of further division. Now we have written the product of all these numbers. It is 210. It is the LCM of these 3 numbers. Now let us find the relationship between LCM and HCF. Here we have 2 numbers 18 and 27. Let us see the LCM of these 2 numbers. LCM of 18 and 27. 18, 2 into 3, 2 3 6 into 3, 18. Now 27, 3 into 3, 3 3 is 9 into 3, 27. So now, what are the common factors? 3 into 3. Now what are the other numbers? 2 into 3. 3 3 is 9, 9 2 is 18, 18 3 is 54. So 54 is the LCM. Now let us see the HCF. HCF of 18 and 27. So here 18 and 27 is 9. Now let us see LCM into HCF. LCM 54 into 9. The product of LCM and HCF is equal to 486. If we multiply the given 2 numbers 18 into 27, we get 486. So what is the relation we find it here? Here we find it, the product of LCM and HCF of the given numbers is the product of that numbers. So that is the relation between LCM and HCF. Divisibility rule for 4. For any number in its last ones and tens place, whatever the digits are there, whatever the number the digits form, if that number is divisible by 4, then this number is divisible by 4. The 57 is not exactly divisible by 4, so this number is not divisible by 4. The divisibility rule for 8. So here is a number. We are going to verify whether this number is divisible by 8 or not. Let us see what is the divisibility rule of 8. If a number, the last 3 digits of the number, whatever the number they form, if that number is divisible by 8, this full number is divisible by 8. Now let us see, this is 90,000 plus 3,000 plus 600 plus 20 plus 4. This is the expansion form of this number. So last 3 places, hundreds, tens, ones, 624. If this 624 is divided by 8, let us say this, the 624 is divided by 8, 78 times. Now let us see this last 3 digits, 624 is divisible by 8 or not. It is divisible by 8, 78 times. So this whole number, the complete number, is divisible by 8. So this is the divisibility rule for 8. Let us see the divisibility rule for 11. So what is the divisibility rule of 11? There is a number. Now we are going to check whether this number is divisible by 11 or not. So here the divisibility rule for 11 is that the sum of even numbers and the sum of odd numbers. See, the sum of even numbers, 6 plus 3, and the sum of odd numbers, 5 plus 4 plus 6. 6 plus 3, 9, 5, 4, 9 plus 6, 50. Now we got the sum of even numbers and odd numbers. So what is the rule? The difference between the sum of even numbers and odd numbers, it should be 0. Then it is divisible by 11. Otherwise, it is not divisible by 11. So here 9, 15. What is the difference? 15 minus 9 is equal to 6. So it is not divisible by 11. So this number is not divisible by 11. Divisibility rule for 11. Let us take a number. Now we are going to verify whether this number is divisible by 11 or not. How do we do that? What is the divisibility rule for 11? The divisibility rule of 11 is the sum of odd numbers, the sum of numbers in odd number places, the sum of numbers in odd number place, and the sum of even numbers. Here the sum of odd numbers in the given number, odd numbers, and the sum of even numbers. The sum of the odd numbers here in the number 2 plus 1, and the sum of the even number 6 plus 8. So this is 3 and this is 14. So if you find the difference between the odd and even number, you should get either 11 or 0. Then the number is divisible by 11. So here what do we get? 14 minus 3. So we are getting 11. So this number is divisible by 11. So what is the divisibility rule here? The sum of the difference between the sum of odd numbers and even numbers of the given number, it should be either 0 or 11. Then the number will be divisible by 11.